Perfect. All right. Welcome, everybody, to this presentation on Second Life battery market and EV residual values. Thank you for your patience as we're getting started here. We have our wonderful panelists on the line. This event is being recorded as well. We have folks piling in from the attendees list here, rapidly increasing. We just passed 40 as well. Given that we're a few minutes after the hour here, we want to jump right into it. So want to note that this event is being recorded and it will be shared afterwards online. We'll be also reaching out to those that have RSVP'd for today's event. So those of you that are online here with an email link to the presentation. So with that, let's get started. Logan, if you don't mind, jump into the next slide. So again, thank you for joining today's presentation. We have a great event lined up with practitioners at the forefront of advancing circular economy for EV batteries. I'm Grayson Shore, the Executive Director of the PNW, the Pacific Northwest Battery Collaborative. And the PNW Battery Collaborative is proud to co-host this event with CALSTART and the New York Climate Exchange. Especially many thanks to Kabir and Neil for their partnership in organizing today's event. Today's event is being run as follows. As you can see the agenda on the PowerPoint presentation here, we'll be doing the co-host presentations, followed by presentations by Moment and Zenobi, followed by moderated and then audience Q&A. And then we'll end with some upcoming events and final announcements. If you do have questions throughout the presentation, we do recommend putting them into the chat box throughout. You don't need to wait. We'll circle back to those audience Q&A when we get to that section of the presentation, but we'll be looking at them throughout. If you do have questions as well, if you're running into tech issues or things of that nature, we have our IT support looking on the back end, so feel free to pop anything into the chat box regarding that. Otherwise, wanted to say we have over 160 people that have RSVP'd for today's event, coming in from places such as India, UAE, Singapore, China, Germany, Sweden, Spain, France, the Netherlands, the UK, the US, Canada, and Kenya. So welcome from across the world. With that, let's get the show on the road. Next slide, please. Perfect. So, and actually, if I can go back one slide, if you don't mind. Thank you. Perfect. So what is the PNW Battery Collaborative? Well, the PNW Battery Collaborative is the largest network of battery professionals in the Pacific Northwest of the United States. That's the upper left corner of the United States. The PNW Battery Collaborative has the following mission. It's a collaborative community of battery entrepreneurs, scientists, policymakers, enthusiasts, united to make the Pacific Northwest the United States' leading hub for battery innovation. Next slide, please. So we host a variety of events over different structures. Over the last 5 months, we've had 479 people attend and RSVP our events focused on a variety of topics, including discussing silicon batteries, direct air capture for graphite, investments into battery startups, utility policy for BSS, and even site visits to places like the University of Washington's battery fab and testing facility, and more. We've had 26 different speakers from organizations across the United States and around the world with titles such as founder, CEO, analyst, advisor, professor, and counsel. Next slide, please. If you're interested in following or participating in future PNW Battery Collaborative events, you can scan some of the QR codes here. You can also Google search for more information. We have a LinkedIn group page and an events calendar. The events calendar is what you use to RSVP for today's event. With that, we'll jump to the next slide. And I'm going to check, do we have Kabir on? If not, we'll jump forward to Neil. Perfect. All right, let's jump forward to Neil then. I know we were having a little bit of technical difficulty earlier here.
I'm here, Grayson.
Oh, you are? Oh, excellent. All right, Kabir. Over to you. So we'll go back one slide and hand it over to co-host from CalSTART, Kabir.
Okay, awesome. Thanks, Grayson. Hi, everyone. Kabir Natt-Carney, EV Industry Assessment Specialist with CalSTART. So before we dive into today's presentation, if you could just go back, I want to tell you a little bit about what CalSTART is in case you aren't aware. If you could just go back to the previous slide. So CalSTART is a nonprofit industry consortium that works with numerous member companies in the clean transportation sector. This includes utilities, this includes EV manufacturers, this includes truck as a service companies. This includes transit authorities. And in partnership with these organizations, we accelerate the clean transportation sector. Besides working with the member companies, we have also administered and designed a variety of voucher incentive programs to deploy zero emission vehicles on the roads, namely a lot of programs in California for both zero emission trucks and buses, as well as charging infrastructure. We're also doing quite a bit of work in the Northeast region, in New York State, and soon in the Pacific Northwest as well, along with the PNW Battery Collaborative. So moving on to the next slide, please. Yes, one more, please. Perfect. So for today's topic, I wanted to share with you all a white paper that CalSTART has put out this past year on the topic of resale valuation of used components from EVs and how this establishes residual values for battery electric vehicles. So specifically, residual values are one of the key financial risks that the EV sector faces. And we are finding that some of the companies that we're featuring in today's webinar are actually innovating a new business model for battery repurposing that is overcoming this financial risk. And this is accomplished by reselling the batteries on the second life market, and as a result, kind of making the EVs cheaper. So, I welcome you to read the paper. It was also featured in Canary Media this past year, and there's QR code for the paper right over there. And really quickly, I can go into kind of a high level finding from the paper. Next slide, please. So in our paper, what we did is we looked at the residual values of battery electric vehicles. In this case, it was a typical battery electric yard tractor. And we compared the RV to the diesel counterparts. And then we also looked at the RV expectation when you look at the valuation of the components. And so what we found overall is that by looking at residual values based on the used component resale potential, this actually makes the RV quite competitive in comparison to diesel. So specifically, the RV is about 15 to 25% after 5 years. And in the battery electric trucks component case, this is much better than the really conservative RV that a lot of lenders currently use for battery electric vehicles. This is quite competitive with a 30% residual value for diesel trucks that are kind of comparable to the vehicle that we model. And then, because the battery continues to retain juice for several years after that 8-year point, the RV for the battery electric vehicle is actually higher than the diesel. And so, this is kind of the high level theory, and I welcome you to read the paper. There's a QR code down there, and really excited for the other speakers on today's webinar to highlight kind of the real life applications of battery resale and repurposing. So with that, I think we'll move on to the next speaker.
Thank you, Kabir, and thank you all so much for joining. My name is Neil Padicone. I'm Director of Green Economic Transformation at the New York Climate Exchange. Next slide, please. It's a real pleasure to co-host this event because this is a subject that's very important to us. But just a quick introduction for those of you who may not be familiar. The New York Climate Exchange is a very new Center for Climate Solutions that just launched in the last year or so. We're developing a physical campus at Governor's Island between Manhattan and Brooklyn in New York Harbor. And the idea is to take solutions to climate that are coming from across our partner network, which in turn includes 12 academic institutions, 3 corporate partners, and about 35 different community partners ranging from labor unions, chambers of commerce, environmental justice organizations, and workforce development and arts institutions. source solutions from there and beyond our network of collaborators, pilot and prototype them at our campus, our forthcoming campus on Governor's Island, and through New York City as kind of a living laboratory for these solutions. Once they demonstrate success, spread them and scale them back across the world. And so invite you to learn a little more about the climate exchange at that QR code in our website, nyclimateexchange.org. Next slide, please. So this issue of battery circularity is very important to us because we've recently launched Project Closed Circuit, which is a program focused very closely on making cities hubs of battery circularity. And, as Kabir has shared, one of the big challenges for fleet electrification, which itself is a major tool in our effort to decarbonize, faces its own challenges because fleets themselves will say, this is a very high upfront cost that I have to spend, but after 8 years of use, 10 years of use, I'll just have to get rid of this battery because it won't serve my purposes anymore. And so this idea of circularity is, can that battery have a second life? Can it be repurposed, remanufactured for secondary uses in grid energy storage, in building energy storage? And so, a lot of the companies that we're going to hear from today are making that work happen. But there are, of course, a number of other hurdles that I'm sure they'll speak about, whether they're regulatory, whether they're policy. And so our Project Closed Circuit really hopes to unite a lot of the research and the work that's happening across and beyond our partner network, see what can happen at the city level using New York as a case study, and try and open up and build a market from the city outward. So we're very excited. I should mention, as you may have seen in Grayson's bio there, that we've recently brought him on as a Circular Economy Fellow to lead this work for the exchange. And so that's why we're excited to closely partner with PNW Battery Collaborative as well on efforts like this. But really stay tuned on a lot of the work that we're going to be advancing. And please do stay in touch and learn more at that QR code. Thanks very much. I'll pass it along to the next presenters.
Perfect. Thank you, Kabir, and thank you, Neil, for your excellent presentations there. Well, it's an absolute pleasure to bring Samreem Ratan and Robert Long on to our next session of the presentation today. Samreem will be starting us off here, and then we'll be followed by Robert. If you do have questions for our wonderful panelists, please do feel free to put them in the chat box. I saw we just got first question in. We'll be looking at those on the back end and then picking what seem to be the best ones and asking those during the audience Q&A. So with that, Samreem, over to you. And next slide, please.
Thank you, Grayson. Hi, everyone. My name is Samreen, and I'm one of the 4 co-founders and COO at Moment Energy. In my role, I oversee our supply chain and operations, specifically on the battery partnership side. But today I'm here to tell you more about Moment Energy. And what we do at Moment is we repurpose retired electric vehicle batteries into energy storage systems. Our vision and mission is to enable all retired EV batteries to be repurposed by 2030 and to use these batteries to provide worldwide access to clean, safe, and reliable power. So who is Moment Energy? Firstly, I will tell you all to take a visual snapshot of the image on the screen so you can understand what our product looks like. But what we do is we solve a two-front problem. The first is ensuring that EV batteries are repurposed in their lifetime. The second is that we ensure that they are put into products like this one on the screen so they can support energy storage applications. Through that process, we help EV battery manufacturers unlock new revenue streams by transforming their retired batteries into these battery energy storage systems, or for the acronym, we call them BESS or BESSes. So some background on our company. We were founded in 2019 and have a headquarters based in Vancouver. We are a market leader in second life battery energy storage, and we've become a leader in the industry through having a very amazing team, as well as our relationships with very strong automotive companies in the industry. So this includes Mercedes, Nissan North America, and over 20 battery manufacturers that all trust us to repurpose their batteries. With their trust, we've been able to create projects that have been deployed in North America using Second Life batteries, and we've deployed 7 of them so far and have an additional 89 projects in the pipeline. And we are the first and only company in North America with a certification called UL 1974, which means our entire process of sorting, grading, and testing EV batteries has been approved by this process, and we go above and beyond that process as well to ensure our systems are safe. But this accreditation has helped us grow our standing in the industry as a market leader. Another key piece of our growth is that we are working on expanding our footprint and building the world's first battery repurposing gigafactory in the United States. So this will help to bring EV battery repurposing in and make the US a market leader in this space. So we are very excited. We have the support of the Department of Energy to support that building. We received a $20 million grant from them to establish this operation to ensure critical material retention, and that we want to make sure that all the materials from the EV batteries are used in their full circular economy lifetime within North America. So why are we repurposing EV batteries? If you take a look at this image here on the screen, you can see that with EV batteries, they spend their first life in an electric vehicle, typically for about 10 years before the driver starts to notice a drop in range. And then that battery ends up being replaced or removed and transitioned into another application. So today, a lot of these batteries end up sitting on shelves or being prematurely recycled. But in reality, they do have 80% of their original capacity remaining, which means they can be used for another 10 years in Second Life applications. So that is what we focus on. It's that middle portion of the image here. And once the batteries are done being used in energy storage applications, we will ensure that that battery gets sent to recyclers to retain the critical materials. Why repurposing EV batteries is also extremely important is that today repurposing EV batteries is profitable, but recycling is not. So we do want to talk about this because in industry, recycling is a huge topic, but reuse often gets missed. And with the recycling of EV batteries, typically this is an out-of-pocket cost for automotive companies or other groups that are trying to get their batteries recycled. And that gets especially exacerbated with LFP batteries, which are very expensive to recycle today. So our hope is that with reuse, we are able to give extra time to recyclers to develop their technologies and eventually get to profitability for the recycling of both LFP and NMC batteries. Now let's talk about the applications of these batteries and how they can be used in energy storage. So the first topic here is about demand charge reduction. So if you imagine a manufacturing facility or a business that has extremely high power draws from the grid for their manufacturing lines, typically demand charges for some of these business owners takes up 70% of their commercial electricity bills. So it can be hundreds of thousands of dollars all the way to millions of dollars per year for some of these businesses, which can be a huge financial burden and can be mitigated by other applications. So rather than drawing electricity from the grid during peak demand times or having an extremely high demand application only for a short period of time, but the utility will see this as a demand that needs to be served for the business and essentially will tax the business according to their energy usage, even if it's only for a short period of time. So what we can do is install energy storage systems to shave off that demand charge and to help businesses retain that money and put it somewhere else. Another really important use case is actually for supporting our grid and ensuring grid reliability. So one example of this is with the expansion of EV adoption and EV charging stations. There has been a lot of load placed on the grid. not just from EV charging, other needs as well that we have taken up as human beings on the planet. But essentially, the grid wasn't designed for these high power demands when it was originally made over 100 years ago. And with that limited grid capacity, our options today are that we can upgrade transmission lines, transformer equipment, and really make these huge infrastructure changes, which takes a lot of time and money. Or we can install energy storage systems in targeted areas where the grid needs that extra support. So this is something that we are doing with our energy storage systems is we do distributed energy resources. We use our systems as DERs to help support the grid and to ensure that EV charging and other high power intensive applications can be supported without putting extra stress on the grid. An example of one of our customers who is adopting our system to support EV charging is Vancouver International Airport. So with YVR, they've invested in fleet electric vehicles, which is really exciting. However, they don't have enough power available from the grid to charge these vehicles, especially when we're considering applications like DC fast charging. So that's where we are partnering with YVR to install our energy storage systems paired with their EV charging stations to enable that charging need. And this is an initial project that will be expanded to face consumer vehicles as well at the airport. And finally, to wrap things up, the powerhouse behind our success is definitely our team. So we have very experienced team members, all the way from having our electrical and mechanical engineers on staff who are certified in fire protection. We are also on the technical committees for UL 9540, 1973, and NFPA 855, which essentially regulates the thermal propagation and fire protection pieces of energy storage for the entire market in North America. So our team is very well versed in these areas. We have experience from very amazing companies in the industry as well. And we're excited to be taking the lead on this space. So I'm happy to answer some more questions as we go through the rest of the presentations, but I'll hand it over to Robert to talk about his company.
Thanks, Marine. Hi, everyone. My name is Robert. I'm Business Development Manager in the Second Life team at Zenobi. And I'll explain what that means by explaining what Zenobi does. So Zenobi as a whole, we design, finance, build and operate battery projects. And back when we started in 2017, that was focused on what we call network infrastructure, but is otherwise known as very big batteries on the grid, connecting to either transmission or distribution level and providing flexibility with the increase in renewables on the grid. We need additional flexibility to manage that. So a recent news release we had was that we have commissioned Europe's largest battery, which is a 200 megawatt battery called Black Hillock in Scotland, and that was 2 weeks ago. But in developing these kind of projects back in 2017, 2018, we were the first to be able to get project debt against battery projects. We also developed our own software capabilities to monitor and control batteries, as well as a technical understanding of how to design, build and operate sites that use batteries, so including all of the infrastructure that is required to support that. So in 2019, we started supporting fleet operators with their challenge of transitioning from diesel vehicles to electric vehicles. For a fleet operator, this is a pretty uncomfortable and expensive undertaking. So we wanted to de-risk it for them, and we did that in two ways. Firstly, by managing the charging, we would come in, design, finance, build and operate the charging infrastructure. So we'd come to their depot, do all of the planning, manage any grid connection upgrades, manage the construction, and then we put our software on it to control it, including managing the charging to spread it out overnight and reduce the total energy cost, as well as the requirement for infrastructure. But the other challenge they had was the cost of the vehicles and the lack of financing, or the lack of confidence from the financing partners they traditionally used in financing this new technology. So we provided two financing structures, one for the battery, and we'd separate that from the vehicle. The reason being that if you're running a bus or a truck, you might want to use that vehicle for 10 to 15 years, but the battery might only be able to do the range you need for 5, 6, 7, or 8 years. And so if you're a fleet operator, it's quite intimidating to have to think about not only buying a very expensive vehicle, but having to consider a battery replacement halfway through that vehicle's life. We offered a solution where we'd guarantee range for the full duration of that vehicle's life, and the customer only has to pay one fixed fee. And we can bring down that fee by committing to a residual value for the battery that comes off. So when the battery can't do the range anymore, we take that battery off, put a new battery on, and the customer can keep on operating the vehicle. They have a fixed cost for that battery or that range throughout the life of the vehicle, and that cost is reduced by this residual value from putting it into a second life. If we can go to the next slide, I can talk about that in more detail. So this is a graph showing exactly what I've just said. Battery range decreases. At a certain point, it's no longer useful for the EV because it can't do the fixed range that is required for that fleet's contract. And so that battery needs to be replaced to restore full range. The battery that comes off can continue to be used for another 5 to 10 years. And that additional value from that second life can bring down the overall cost of that vehicle. If we can go to the next slide, please. So everyone is interested in the residual value of the battery when it comes off. But what we try to explain to our customers and other fleet operators is that actually the best value you can get out of your battery is by extending its life on the vehicle before it comes off. And this graph shows that you might have a vehicle whose operations require them to have could require them to have 2 battery replacements throughout their life. But if you can control or reduce the rate of degradation by managing how the vehicle is driven, so improving the efficiency and how the fleet operators drive the vehicle, and secondly, how you charge it, so spreading out the charging and looking after that battery, then in fact the first goal should always be to extend the life of that battery. And by doing that, you could even avoid the cost of a whole new battery. So that's obviously the best value you can get from a battery, is avoiding the cost of a replacement. But also with the time value of money, if you can delay that replacement, then you can reduce the cost of a replacement battery on your TCO. But eventually that battery needs to come off. So please can we go to the next slide? Just very quickly, although I'm sure most people joining this call know this, here's the economy or circular economy for a battery. So it's procured, goes into its first life, that battery comes off the vehicle, then some work needs to be done to it in refurbishing or repurposing, and it can then be used in a second life application. Eventually, when it can't be used anymore in that second life, it goes to recycling. Some materials are disposed, but the majority of materials can go back into the battery manufacturing cycle. If we can go through to the next, please. So Zenobi has committed. So what's different from potentially some other use cases is that it's not the fleet operator trying to find a use or a market for the battery when it comes off. Zenobi has committed to that residual value. So we are, on our business model, we're assuming we can make that residual value, and we therefore are committing to a lower cost up front for the customer. Now, we now have around 2,000 vehicles contracted where we need to find a way of realizing that residual value. And we've tried a few different applications, and one of those is in portable power. And that is using mobile battery systems to reduce or replace the use of diesel generators in a few different industries. So very quickly, we've used mobile batteries to peak shave limited grid connections. So for example, powering a tower crane, which would otherwise require a very large generator, you can instead trickle charge from a small grid connection and power that crane. That's quite a nice use for a second life battery because you are not requiring heavy energy usage, but you are utilizing its ability to provide lots of power in a very small amount of time. We can also use them in hybrid with diesel generators. So instead of a big generator running 24/7, you can use a battery to control to run the generator only a few hours a day and at its most efficient rate. Once again, you're not needing huge amounts of capacity to provide this service. You just need something which is able to provide a buffer between the generator and the load and ensure that you're running it most efficiently. And then in an ideal world, you can use completely clean and mobile generation sources to recharge that battery. So we've used hydrogen fuel cells, we've used solar panels, and we've used others to charge in off-grid applications. And these can be used across events, temporary charging for ports and for boats, temporary charging for fleets, and also for construction, and then finally backup power for heavy industry that usually uses diesel generators. If we go to the next, please. So here's a case study of where we've used this for a temporary charging application. If you can go through, please. So we're going all the way from Vancouver Airport down to, next slide, please. I did check this. There's a direct flight, so you could go to Vancouver. You could visit Moment Energy's Second Life battery there. You could fly down to Auckland, and within 5 minutes, you could be at one of our Second Life battery projects, which is at a fast charger nearby. What this battery is being used for is a company called Z Energy, who own a lot of petrol stations, are installing rapid chargers. However, they are wanting to test out which areas are going to have high utilization for EV charging before they commit to upgrading the permanent infrastructure. So on this site, they wanted to test out a fast charger, but they only had a 50 kilowatt grid connection. So rather than upgrading that and putting a charger in, they wanted to put the battery in a semi-permanent installation. So what we do is we trickle charge that battery with the 40 kilowatt grid supply, and we provide the additional 40 kilowatts from the battery to peak shave. If we go to the next slide, we can show how that looks on a graph. So what that looks like is the red line is, you can see the grid supply that is being kept at around 40 kilowatts. The blue line shows the demand from the charger, and the green line shows when the battery is discharging. So what you'll find is that the combination of the red line and the green line is the combination of the grid and the battery. And you can see that when the battery is not discharging to support the grid and provide the power for the EV charger, it is recharging in between. And what this shows is how you can have a very nice, relatively plug and play, but dynamic and smart, flexible system to reduce the need for permanent grid upgrades if you have grid connections which are either delayed or unattainable, or you just have a temporary project where you don't want to commit to that investment for the permanent grid upgrade. We see this actually as a very nice way of many fleet operators trialing going electric before they want to commit, especially with HGVs. There is a hesitance to commit to full electrification, and we find that being able to use Second Life batteries to provide temporary charging is a nice way to, one, have them have a less committed solution to try electric charging, but also demonstrate that Second Life batteries can have a use and that a residual value can be attainable, and so they can have less concern, or they can at least reconsider their TCO models and maybe improve them slightly when they're considering the investment in going electric. Thanks very much.
Wonderful presentations. Wow. We've got some excellent questions in the chat box too. So we do have some prepared questions, and panelists, if you don't mind turning your video and coming on as well. We've got some excellent questions prepared for our panelists, but we may just limit it to one of those per panelist, and then jump into the audience Q&A. So if you do have questions, keep them coming through the chat box, and we'll jump into those in just a moment here. With that being said, let me just jump back to my notes here. All right, so Kabir, let's start with you. What does battery circularity represent as an opportunity for fleets moving forward or moving towards zero emissions? What does it mean for financing?
Yeah, so I think Robert, for instance, really covered what this means, what Second Life batteries mean for fleets in terms of financing, right? Because by guaranteeing the resale of the battery at the end of life of the vehicle at a set price point, this reduces the leasing gap or the financing gap during the vehicle's term. And so that ends up meaning that the annual lease payments or the financing payments are lower as a result. And so, by essentially guaranteeing the end of life resale at a certain price point, you've made EVs cheaper, which I think is such a great business model. And it also happens to reduce waste.
Absolutely. I love the point about reducing waste as well. So excellent response there, Kabir. Samreem, over to you next. What makes Second Life EV batteries suitable for energy storage applications?
Yeah, that's a great question. So with EV batteries in particular, they are designed for very high charge and discharge applications, being in electric vehicles themselves. For those of you who are technical, you would understand there's extremely high C rates that can be applied to these batteries. And now, when we use them in energy storage applications, even though the batteries are at 80% state of health when they come to us, it is a much less stressful application on the batteries. So they're designed for those high charge and discharge rates. We retain those features in Second Life, but since we are using it at a lower charge and discharge rate, lower C rates, we can actually extend the lifetime of that battery and continue using it in this less stressful application outside of the vehicle.
If I can jump in with the moderator's privilege here as well, I've seen previous estimates that an end of life, and there's some questions to this in the chat box too. So there's some estimates that a Second Life be a EV battery repurposed as battery energy storage system can last for about 5 years. But my understanding is that Moment has worked it out that they can extend for about 10 years. Is that correct? Can you speak a little bit to the duration of time that these can be used for?
Definitely. Yeah. So the duration of time does depend on the customer itself and their use case. But if we're estimating that our customers are cycling these batteries once a day, then we can have them last for 10 years for their applications. So it is quite significant to be able to say that this battery is going to be used for another decade outside the vehicle's life, which is why it's so important to make sure that we don't skip the step of reuse and prematurely send these to recyclers, or worse, send them to landfills to get toxically rid of.
Totally agree. Keep them at their highest value for as long as possible. Love that. Robert, over to you next. So, Robert, how do you manage perceived performance risk of using Second Life instead of First Life batteries for your customers?
Yeah, thanks, Grayson. I mean, I was talking to someone earlier and I said, if I offered you two options, here's a brand new battery with a 10-year warranty, or here's a Second Life battery, which, should probably do the job. People might prefer to go for the first option. And the way that we manage that is by doing the same thing we do with our fleet customers. So we do battery as a service, and we don't say to the customer, you are paying for a battery. We say you are paying for a solution that will meet your requirements. So when it's on the bus, we're guaranteeing you the range you need to deliver on your route for the life of your vehicle. And with a Second Life battery, we're guaranteeing you a battery which will power your crane, power your festival, charge your excavator, whatever it is. And it's on us to manage the battery's performance to support that. And that means that we will send some batteries onto one application and some batteries onto another application, or rotate them between that, but always using kind of battery intelligence and monitoring to manage that risk on our side and ensure the customer has a guaranteed solution. That's the way that we overcome it.
You got some great shout outs for that, Robert, in the chat box as well. And that the financing structure being very wise, very smart in that sense. So very cool approach. And I got to ask, what do you have behind you as well? What's in your background?
This is an electric school bus, which is one of the projects we are deploying this year in the US. I couldn't tell you exactly where it is, unfortunately.
Very cool. Excellent. All right. Well, with that, Kabir, I think you have a question for me, and then we're going to jump into audience Q&A, which, wow, there are so many questions rolling in. So we're going to have some fun time on that.
Yeah, sorry, Grayson. Do you mind going over to the audience Q&A, and then I will pull up the question for you.
Perfect. That sounds great. All right, so let's jump into audience Q&A here. All right, so I've been taking some notes as we're jumping through these, and wonderful questions. I'm going to try to answer, kind of bunch these together because there's some overlapping questions or complementary questions. So let's start first with a question from Ken, and apologies, I'm looking over to my other screen here. So how we'll do this is if a particular panelist wants to answer this question, just go off mute and feel free to jump in first here. So first question from Ken: is there increased safety with Moment Energy BESS versus original lithium-ion based BESS? Or are the concerns around thermal runaway equal for Second Life EV batteries as with original units? So Simreem, over to you.
That's a really great question as well. Safety, fire safety is extremely important, and that's a core value and focus of what we do at Moment Energy. So we test these batteries rigorously. So firstly, through when we receive our batteries in our facility through our UL 1974 process, it is very comprehensive with the testing, grading, and sorting of the batteries themselves. And then when we come down to the system design, it all has to be compliant with UL standards, which apply to both first life energy storage systems and second life BESS. And when I talk about these standards, I'm referring to UL 9540, the test methods under that 9540A, as well as UL 1973, which are all recognized in North America. So when we put these batteries through those different test scenarios, that's how we ensure safety along with other metrics. We have a battery management system that we have developed as well that handles the variation in second life batteries effectively and also helps us reach those lifetime requirements like the 10 years that we offer to our customers. And on top of that, because second life battery systems are less energy dense than first life, there is an inherent safety improvement there as well. So there's lots of different things. I would say it ranges from the rigorous testing all the way to the system design itself.
Awesome. Thank you, Smarima. We're going to come back to testing, insurance, and things of that nature. There's some wonderful questions on that topic in the chat box here, but I want to jump down to a question by Geo. GeoPhil had asked, what progress has been made on battery recycling? Are we on track to have cost-effective recycling by the end of second life, or are we just kicking the can down the road?
Yeah, so what we've seen with recycling is that for NMC recycling today, there is a small credit provided for that specific chemistry. Typically, that credit gets negated by transportation costs, but it's still good that it can come down to $0 to recycle. However, with LFP batteries, because these batteries haven't been around for that long, we do expect that there will need some time for that to become profitable. But that being said, there are recyclers that are working on it. It's really a question of reaching out to some of the recycling companies to see where they are at with the technology. But I would expect by the end of the decade, or at least hope, that there has been improvement on that.
Awesome. I'm going to jump a question over to Robert and Kabir on this one as well. This is by Katrina. Katrina Sutton. She had asked, is there ever an instance when a battery would be better to recycle instead of being used as second life battery? Robert, Kabir, any thoughts on that?
If I jump in here, yes, if you take a residual value for a second life battery, if you already own the battery, then the residual value is effectively equal to the value of the cash flows that you can achieve in a second life operation minus the cost of getting it from the vehicle to that second life. So depending on the condition of the battery or the type of battery, it might either be that the cost of integrating it is too high because there's a very small batch, and so the cost of making a new design to house it is very high, and so you have to allocate all that cost to a small batch of batteries. Or it could be the battery's in a condition that the lifetime is not going to be its second life is not going to be very long, or not going to perform very well to earn enough money. And so if you can't net those off to have a positive value, then you effectively wouldn't want to repurpose that battery. So really, it's a case of being very efficient and smart with how you repurpose your batteries and which batteries you repurpose.
Absolutely. You mentioned a bit about chemistries as well, indirectly in that sense. I know, Samreem, in your presentation, you talked a little bit about the different recycling values between NMC batteries versus LFP. And for those that had joined after that portion of the presentation, there's just not really, the economics don't work out today to recycle an LFP battery as compared to an NMC. And what you would get for an NMC is just kind of hundreds of dollars or even pennies on the dollar if you factor in the overall cost of a battery. But interestingly enough, an LFP battery is much more, much a better fit for second life use than an NMC battery is, in large part because of the safety components or the safety characteristics of an LFP battery versus an NMC battery. On that particular point, there's a good question by Brian. He asks, he would like to know more about how you manage a battery pack or module variations. In particular, do you take any specific actions relative to fire safety? I know Samreem UL 1974, I think you're one of 2 companies in the world that have the certification, with the other one being in Japan. Curious if you have any thoughts on fire safety and Robert, Kabir, curious your thoughts also if there's a handful of questions on fire safety throughout the chat box. So any general thoughts you would want to mention on safety and insurance liability would be wonderful to hear.
Sure. With the fire safety aspects, that is something that we test for when we go through UL 9548 testing or other R&D tests that we do internally. So that includes seeing, how does, if you do force propagation between cells, how does that end up affecting the full module or pack? Is there propagation if you don't force it? So these are different scenarios that you can test for. And that is what we do. So these batteries that we receive have not only been tested in their first life in the vehicle or for their first life, but they've also been retested for second life applications, which is, it just tells you the extent of which companies like us will go to make sure that they are safe. But as far as the variation between different types of modules and packs go, we do have to design around different types of variations in our system. So it does become a challenge for Second Life companies to be able to do that. However, our goal is essentially that we are able to accommodate different types of packs and modules within the same system architecture. And that's something that we patent for as well through our designs.
Amazing. Robert, Kabir, anything to add on that?
Yeah, I was just going to add, kind of thinking about, this specific issue along with a question that Michelle had asked kind of earlier in the webinar about, as you see these variations, how do you convince commercial banks to lend against Second Life batteries? And it still seems very theoretical, and oftentimes the standards are very different. To that, I think I would say, there are a lot of emerging standards that are required, and I think any sort of lender that is lending against battery second life should really think about those and consider the standards in Europe versus in the US. I know there's slight variation. I think another answer to that question is, there is a role for catalytic capital to get lenders comfortable with this idea that, some of the leading companies that are presenting today are actively implementing, but is not, entirely kind of at commercial scale just yet. So what comes to mind for me on that topic is the California zero emission loan pilot, which has been a great way for lenders to lend against zero emission trucks and address small fleet credit risk. And a similar type of loan guarantee structure might be applicable in the case of battery second life. And so, as philanthropic investors, VC investors, green banks, et cetera, are looking to support the zero emission transportation sector, and also kind of propel the battery second life business model forward. That might be an area of innovation coming up.
Great answer, Kabir. I'm going to circle back to you in a moment too. There's a question from Bhushan in the chat box, a bit on financing and things of that nature. But before jumping into that, Robert, anything to add on testing, liability, insurance, things of that nature?
Yes, you do not want to put a battery into a second life if you're not comfortable that it's going to be safe. So test, there's two aspects. There's making sure that you've tested and you're comfortable with the condition of the battery modules themselves. And then there is also the housing and the system that you're putting them into, and making sure that you are using multiple stages to protect or protect the battery. So the first stage is always with the BMS, making sure that you're always operating a battery within sensible temperature and voltage limits. And then you'll cut off the battery if there is any breach of those. So you cut it off before it can reach a dangerous point. Then there's reactive measurements, so reactive measures, so making sure that you have heat and smoke detection and fire suppression gas, as well as then suitable housing, and finally emergency response plans. You've planned the design of any site, and you have an idea of what to do if there is an emergency. Because even if you have the safest battery in the world, if someone misplaces a cigarette or something in the wrong place, there's always a chance that a fire can occur. So just making sure that you've planned and mitigated for that for any kind of battery, whether it's first or second life. And in fact, all these things I'm saying are the same whether you're using a first or a second life battery. You just probably want to spend more time on it if it is a second life battery because of the potential increased risk.
Absolutely. There's actually a question on this as well. Trying to remember who had asked it in the chat box, but essentially, can you take batteries of two different chemistries and put them into the same second life BESS? Is that engineering? Is that feasible? Is that safe? What would you say to that, Robert?
Yes, what you have with different types of batteries is you have different voltages, so you need a way to manage those voltages. Normally, we would have the same type of battery in one string, but you could have uh, different batteries in different strings, and you can combine them. You just have to match up the voltages and ensure that things like your racking, your cooling is suitable for each type of battery, and you've covered off any risks specific to different battery types.
Amazing. So I think we have time for about two more questions here. I'm going to jump to this question from Vishant. I think this is a wonderful question. He says, if there is a cost advantage right now, how do we plan to sustain that a new BSS price, the downward trend? Well, let me rephrase the question here a bit. In other words, we're seeing that batteries, the cost of virgin material batteries have gone down by about 20% last year, and that's the biggest drop since 2017. So we're facing these kind of market pressures for reuse, and that the virgin material batteries are just getting cheaper and cheaper. I think we're $115 per kilowatt hour in 2024, and in China, I think for LFP they got to somewhere around $50. So super inexpensive compared to where they were even just 5 years ago. How does the second life BSS industry compete with cheaper and cheaper batteries?
I can take this one, then I'll pass it to Robert to add any thoughts that he might have as well. But what we've experienced is that as first life battery prices have dropped, second life prices have also proportionally or even more, they have also dropped. So even when we look at our own purchase agreements from when we first started 5 years ago versus today, there's been a 40% decline in battery prices, and we expect those to further decline and come down to even $0 a kilowatt hour at some point, because what we're seeing is that the influx of batteries, second life batteries from the industry is getting to a point where OEMs, automakers, they just want to get these batteries off their hands. So when we're taking these batteries, we are essentially taking on that responsibility that this is going to be put into a circular economy. They no longer have to worry about them. We take care of the full testing and safety and deployment aspects of it. So that's something to keep in mind as well, is that we're solving more than just the problem of creating energy storage systems. We are also solving a massive problem for partners who need to find a sustainable way to handle the batteries.
Excellent point. Robert, Kabir, anything to add on to that?
Very, very quickly on that, yes, if you take the value of a second life battery is proportional to a first life battery, and the first life battery prices are dropping, then the value of a second life battery is also dropping. And from someone maybe like some Marine's customers, that's a good thing, because you can have a cheaper second life storage system. From our side, as an owner of the batteries already with a residual value, that can be a challenge we're facing. You have to provide more value with your second life battery than perhaps is just commoditized. So by providing a second life service, you can create value around that battery in order to achieve that residual value. But it is worth thinking, in the long run, if first life batteries keep coming down and there is no incentive for using second life batteries, then there is going to be a limited market, and the West is going to be flooded with old EV batteries, which are perfectly good to be reused, but are just continuously buying more batteries from the likes of China. And then there's going to be a bit of a challenge for governments to overcome.
Absolutely.
Yeah, I was going to quickly just add kind of a point for consideration moving forward. I haven't, done research on this topic precisely, and I think it's still an evolving issue. But import tariffs, right, apply on new batteries in a way that they don't apply for.
Hi, everyone. Welcome back to our recording for the Second Life Battery Market and EV Residual Values webinar. We're so sorry about the tech error that we had earlier. The recording got cut, but just Grayson and I just wanted to hop on again to complete the recording. And, first of all, I would like to thank Grayson. I'd like to thank Simreen, Neil, as well as Robert for sharing some great slides today and answering some fantastic questions. And finally, I will hand it off to Grayson to wrap up.
Awesome. Thank you, Kabir. So a couple of upcoming events here we wanted to flag. First is an event by the PNW Battery Collaborative happening on April 9th in Portland at the Metro Region Innovation Hub. If you're interested in attending, you can register via the link at the bottom there. It's an in-person event. And we'll have food and drink and things of that nature, and good conversations about batteries for some experts leading battery innovation in the region. You can read more in the link there. Secondly, and lastly, is from the New York Climate Exchange. We've recently launched our Sustainable Solutions Challenge. It's an open call for implementation-ready innovations that can be integrated into our 400,000 square foot campus that's being built on off the coast of Manhattan on Governor's Island. Note that the deadline to apply is April 1st, and you can apply through the link that's there on the page. I'll lastly just say, to follow up on what Kabir had said, wonderful event. Loved the slides and the questions that were asked, and loved all of the engagement. We'll be having future events down the line, so definitely stay in tune, follow our respective organizations for more events. And I know, Kabir, maybe we have to have a part 2, another CALSTART, PNW Battery Collaborative, New York Climate Exchange event on EV battery circularity. So yeah, I'm looking forward to that.
Yeah, fantastic. Thank you so much, Grayson. And thank you all.
Thank you.